Hello guys, today we are talking about the linear acceleration of a rotating body. Okay, here we have two bodies which are solid sphere, and we applied a force in the middle of the body, and so the acceleration of the body will be F by m. Here we have the mass of the body, but what will be the acceleration, linear acceleration of the body when it is rotating and moving forward? Okay, when it is rotating and moving forward. Okay, the body is rotating, so we have to consider all the calculation, like all the calculation in angularity, that we have to take torque. We have to take torque is equals to I alpha. The torque is equals to the I times of alpha. Then we can write here is that F cross R sine theta is equals to I alpha. What is the theta between the body and the force? Is 90 degree. So F cross R sine theta is equals to F R is equals to I alpha. Okay, then what will be the I? If we look carefully, we can see that the body is rotating and going forward. If a body is rotating and going forward, we can assume that the body is only rotating above the point P, which is the tangential point of the body on the horizontal plane. Okay, uh, because it is a solid sphere, then the then uh, we have to determine the rotational inertia. Then what is the inertia? Okay, the inertia will be like summation of I is equals to the inertia about the middle point, and and plus of the point that we consider about P. Okay, if we know that for a solid sphere, the rotational inertia will be like 205 mr square, where 205 mr square is the rotational inertia of the point of D, and we have to summate it plus mr square. We use the parallel theory of the rotational inertia. Okay, then comes here 7 by 5 mr square. Okay, now we put the answer here. If r, the r is equals to r. Okay, so this is equal, and we have to take 7 by 5 mr square. Okay, mr square alpha. So if r 7 by 5 mr square, we can write a by r to alpha is equals to a by r. We can write. Okay, then what is the value of the acceleration? Here is the acceleration. A is equals to 5 by 7 5 by 7 f by m. Okay, 5 by 7 f by m. Here is the acceleration. So here is the acceleration of the body. If we compare the acceleration of the body to the acceleration of this, we can see that the acceleration is less than the acceleration. Okay, if we consider it a2, and if we consider it a1, then we can write a2 is less than a1. Okay, now come to an example. We have a very important example, like here we have two two round shaped body. One is a solid sphere and the another is a cylinder. Then we apply the same force on the same mass of the body, same masses of the body. Then what is the acceleration of this? We know that the acceleration will be 5 by 7 F by m. Then what is the acceleration of this body? Okay, we know that we have to counter it, like torque is equals to I alpha. Okay, what is the torque? Fr. We know that Fr I is equals to I is equals to a half. We know that I will be half m r square plus m r square into alpha a by r. So if r is equals to 3 by 2 m r square a by r, then a will be 2 by 3 of f by m. Then what is the comparison between the acceleration of the solid sphere and the acceleration of a cylindrical body, like a1 and a2? We can see that we can see that we can see that the acceleration 5 by 7.71 f by m and 2 by 3 of 0.67 f by m. So if we apply the same force on the same forces on the body of solid sphere and the cylinder, then the acceleration will be different and the acceleration a1 will be greater than a2. Okay, the solid sphere will move faster than the cylinder. Okay, here is a theory, important theory. Okay, now I have a very important example in the Howard in a book of Resnick Halliday, where they want you to know about an problem that if there is an inclined plane and we have a solid cylinder here, solid cylinder here, and same inclined plane and a solid sphere here, then what will what will go faster to the ground? What will go faster to the ground, and what takes the small time to reach in the ground? We know that the acceleration 1 and acceleration 2, if we take, then y is less than a2, then then it can be knew that the cylinder, the solid sphere will reach the ground faster. Okay, here a1 is equals to g sine theta. It is theta. If it is theta, then sine theta by 0.6 into sine theta, and a2 is equals to 0.71 into g sine theta. Okay, here we go. Thank you everybody for seeing this video. It is very important for physics students to know about the linear acceleration. What happens when we apply same forces on different bodies? The acceleration varies because the geometrical the geometrical uh, the geometrical the geometrical depends on the depends depends on the shape of the body, that how the masses are distributed. that how the masses are distributed. Okay. Okay, thank you. And and